Hello. Today we're going to talk about topic 2.6, which is certain algebraic rules for derivatives. We're going to touch on constants, sums, difference, and constant multiples. And then we're going to apply that to some of the topics that we've discussed in some of the previous notes. So we have three properties here of derivatives. The first one, and something I've touched on briefly before, is the derivative of a constant. If you take the derivative of a constant value, well, a constant function always has a zero slope. So that slope will always be horizontal. So thus, the derivative or the instantaneous rate of change for any value, for any x value of a constant function will always be zero. Okay, and that's very helpful to us in some later problems. The next is, let's say I take that constant c and I multiply it by a specific function. Well, anytime you have a constant multiplier, that constant multiplier can come out front of my derivative, and then I'm just left with that constant times f prime. Okay, so you can always factor out, if you will, or you can always take out a constant multiplier from your derivative. Some difference rules. If you're adding or subtracting two functions, you can always take the derivatives of them separately, okay? And then just add or subtract their derivatives together. All right, so let's try to apply some of these rules. Feel free to pause, rewind, fast forward, as needed. I'm just going to go through each one of these one by one using proper notation, okay? So if I want the derivative, I'm going to say f s prime of t, and I'm going to use the power rule. So I'm going to drop the 3 down, t now squared. All right, plus, now if I drop the 2 down, that would be a 10 t to now the first. You don't really have to write the first. Minus negative 3. Now this was to the first, so it would be just negative 3 t to the 0. And then the 8, the derivative of a constant, is 0. So what I get here is a 3t squared plus 10t minus 3. This is my derivative, okay? And I'll keep that derivative, that s prime up front. All right, let's go to number 2. I'm going to take the derivative of f, so I'm going to have an f prime of x. Derivative of 8x is just going to be 8 because it's linear. It'll just go to a constant. Now, I want you to think about this fraction. This is 3x to the negative 2 power, right? So I wrote it as a power so I can take the derivative quickly. So if I drop that down, I'm going to get a negative 6x to now, if I lower it a full degree, it'll now be to the negative 3 power. So I get f prime of x equals 8 minus, and I'm going to write this as 6 over x cubed. Okay, and this would be my derivative. Number 3, I have some radicals. Well, I'm going to go ahead and rewrite those radicals as powers. So before I take the derivative, notice I'm just leaving this as f of x. I want to write this as x to the 1/2 minus 6 times x to the 1/3. Now, ultimately, the 6 doesn't make too big of a difference because it's just a constant multiplier. But if I take the derivative here, I'm going to drop that exponent out front. I'm going to lower it a full degree, which would now be a negative 1/2, minus, if I do 6 times 1/3, that would be a 2x. If I lower it a full degree, I get a negative 2/3. Excuse me, bless me. Okay. So if I now write this so that it doesn't have any negative exponents, that would just be a square root of x on the bottom and minus 2 over, this would be, you can either write it as x to the 2/3, or I just want you to know, just in case multiple choice, I want you to be able to match your answer. This is the same thing as saying the cube root of x squared. So those would be the same, okay? So either of those answers would work, okay? All right, on to number 4. Now I have a product here. It's probably in my best interest here to just distribute that product out first. So I'm going to get a 2x to the 4th minus 3x cubed. And now to take the derivative, I'm going to drop my power down, which would be an 8x to the 3rd minus 9x squared. Okay. Again, just using that power rule. If you notice, each of these problems has multiple terms. We're using sum and difference. Some of those terms have coefficients. That's the scalar multiplier or the constant multiplier. We even had some constants that went to 0. So let's show some numerical representations of this. Given this table of values, I want to try to perform these operations. So first, if I want h prime of -1, I want to know what h prime of x is going to be first, and that's going to be f prime of x plus g prime of x, okay? Because I could just take the derivative of each of those separately. Now, when I do that, if I want h prime of -1, that means I just want f prime of -1 plus g prime of -1, and I'm going to look to my table for those answers. So f prime of -1 is 22, and g prime of -1 is a -12. So if you add those together, I get 10. All right. So let's do the same thing for the next one. I'm going to start by finding h prime of x. So that would be 5. Well, that's a constant multiplier. I don't need to take the derivative of the 5. But I do need to take the derivative of f minus the 2, same, that's a constant multiplier, times the derivative of g. And if I want h prime of 0, I'm going to get 5 times f prime of 0 minus 2 times g prime of 0. And I'm going to use my table to find those answers or those values. F prime of 0 is 19. G prime of 0 is 4. So what do I get here? I'm going to get an 95, I believe, minus 8, which would ultimately be an 87. Okay, so let's keep going. Last one. If I take the derivative, let's start with what h prime of x is going to be. So I'll get a 6 f prime of x plus 2 g prime of x. Now, if you notice, this last term is just a cubic piece, so I'm just going to use power rule on it. I get a negative 27x squared. So now I'm going to plug in a 2. So I get 6 f prime of 2 plus 2 g prime of 2 minus 27 times, and I'm just going to go ahead and do 2 squared is 4. Now I'm going to plug in my values. So f prime of 2 is a -5, so 6 times -5, plus 2 times g prime of 2 is 8, minus 27 times 4 is going to be 108. Okay? So let's finish this off. I get a -30 plus 16 minus 108. If you combine that, -30 plus 16 is a -14. Minus 108 is going to be a -122. And that will be my answer. Okay. Now, so this was numerical. This was from a table. This was algebraic. I do have some graphical questions here, right? So let's take a look at these questions here. So same idea. I want to start with p prime of x would just be f prime of x plus g prime of x. And I want to know p prime of 0, which would be f prime of 0 plus g prime of 0. So what is the slope of f at 0, right? So what is the slope at 0? The slope of this linear piece is just going to be a positive 1. The slope of at g at 0, so that's the second graph, is a horizontal piece. Well, the slope of any horizontal piece is 0. So I get 1 plus 0 is just 1. Okay? So again, I'm just using the graphs to get the slopes. So let's take a look at the number 6. I want p prime of x, which would be 5 f prime of x minus 2 h prime of x. So I want to know what p prime of 2 is, which is 5 f prime of 2 minus 2 h prime of 2. So if I do this, f prime of 2 is that slope, which the slope of that linear piece is a negative 1 minus 2 h prime of 2. Well, that's just this piece over here. So let's figure out what h prime is. It's going to be an 8x minus 0 because 9's constant. If I plug in 2 into this, I'm going to get 8 times 2, which is 16. So let's finish it off. I get a negative 5 minus 32, which gives me a negative 37. All right. Last but not least, number 7. I'm going to erase some of this to give me room for my next problem. Again, feel free to pause, rewind if needed. Okay. I'm going to start with p prime of x, just like I always do. Let's take the derivative first. Let's show our work. So I get 6f prime of x plus 2g prime of x. You gotta get used to the notation. You gotta get used to writing things out. Minus 9 h prime of x, and then plus 1, but the derivative of 1 is just 0, so that 1 would go away. So now I want to know what p prime of negative 3 is. So I want 6 f prime of negative 3 plus 2 g prime of negative 3 minus 9 h prime of negative 3. And if I plug in negative 3, the slope at negative 3 for f is a positive 1. The slope of g at negative 3 is also a positive 1. And the slope of h at negative 3, well, we have to figure that out. Remember, we said h prime of x was an 8x, and the derivative of 9 was 0. So if I plug negative 3 into that, that's going to give me a negative 24. So I'm going to get 6 plus 2 plus, let's see, quick math here, 9 times 24 is 216. Okay, fingers crossed that's right. I did that in my head real quick. Okay, so if I do 6 plus 2 is 8, plus 2 is 16, I get 224. My pen to write here. Okay, all right, and then that would be my derivative. So taking the derivative of each piece, using the information that's given to you to then come to your conclusion. All right, so now I want to apply that to a topic we talked about in previous notes. is tangent lines, right? And this is where we're just going to finish off. So if I give you a function and I want the equation for the tangent line at 1, now remember, for any tangent line, you need a point and you need a slope, okay? Now my point is going to be 1 comma f of 1. My slope is going to be whatever f prime of 1 is. Okay, so little notes there to help you figure these things out. So first thing is I know my x value is 1, but I want to know what f of 1 is. So I'm going to say 1 squared plus 5 minus 3 times 1 to the negative 2. Okay, now I have 1 squared is just 1 plus 5 minus 3 times 1 to the negative 2. Well, 1 times 1 to any power is still going to be 1. So it'll still be minus 3. And if you reduce this, you get 3. So I know my point is 1 comma 3. Excuse me here. And then my second, I want to know f prime of 1. So first let's figure out f prime of x. So the derivative of x squared would be a 2x. The derivative of 5 is a 0. The derivative of a negative 3x to the negative 2 would be a positive 6x to now the negative 3. Remember, you lower it a degree, subtract 1 from the exponent. So if I now want f prime of 1, so I want the slope at that point, I'm going to have 2 times 1. I don't really have to worry about the 0. 6 times 1 to the negative 3. So I'm going to get 2 plus 6, which is 8. So I know the slope is 8. So my tangent line, I can say, is y minus 3 equals 8x minus 1. We always get this to be y equals. So add the 3 over. I would take this as an answer. You can distribute it. So y equals 8x minus 8 plus 3. And you can combine like terms, 8x minus 5. And this would be your slope-intercept form. Okay. Number 11, we're going to do the same thing. So again, feel free to pause it if you want to try to do it on your own. We need a point. We need a slope. So I know my point is negative 1 comma f of negative 1. And I need to figure out what f prime of 1 is, right? So I need these two pieces of information in order to write a tangent line. So let's use red here. I'm going to change colors. Okay, so f of negative 1 would be 2 times negative 1 to the third plus 6 times negative 1 squared minus 1, which is a negative 2 plus 6 minus 1, which gives me 3. Now I want to figure out what the slope is. So f prime of negative 1 would be, well, let's start with f prime of x. Let's keep our notation good here. So f prime of x is going to be a 6x squared plus 12x plus 0. You don't really need to write the 0. F prime of negative 1 then would be 6 times negative 1 squared plus 12 times negative 1, which gives me 6 minus 12, or a negative 6. So I have a point at negative 1 comma 3, and my slope is a negative 6. So I'm going to say for my tangent line, y minus 3 equals a negative 6x plus 1, or y equals a negative 6x plus 1 plus 3. So I would take that as your tangent line, or if you want to distribute, I would get y equals a negative 6x minus 3. Okay, and that would be my tangent line. Okay, so just kind of quick review, talking about properties of derivatives. So taking the derivative of functions, and then I wanted to show you some examples algebraically, some examples numerically, and some examples graphically. Okay, if you have any questions, feel free to contact.